Hello everyone, welcome back to another AP Physics 1 daily problem. Sorry for not uploading lately. I've been trying to adjust to a new setup and a new way to record these videos to have the better quality for you guys. That's why the audio may sound different today and the display might look different, but this is just to see and experiment with the way. So with that being said, today is a kinematics problem. So with that being said, let's go on with the question. It says the target T lies flat on the ground 3 meters from the side of a building that is 10 meters tall, as shown above. A student rolls a ball of the horizontal roof off the horizontal roof of the building in the direction of the target. Air resistance is negligible. The horizontal speed with which the ball must leave the roof is if it is to strike the target is most nearly, and we have our answer choices. So here we have a projectile motion problem, and the question is asking us to find what the horizontal speed is going to be. So with that being in mind, we need to go ahead and use our projectile motion equations. And we have two types of projectile motion equations. We have the one in the y direction, which is delta y is equal to v in the y times t plus 1 over 2 at squared, and this is all in the y. And we also have delta x is equal to v in the x times t plus 1 over 2 a in the x t squared. Now, first thing I would like to do in any physics problem that I would recommend everyone to do is to list our known variables. So we know that our delta x, which is the ground, so here in our x direction, our delta x is going to be 3 meters. So we're going to go on the right, we're going to write delta x is equal to 3 meters. And then we're going to see that our delta y, which is the height of the building, is 10 meters tall. So right here, this is our delta y. So we're going to say delta y is equal to 10 meters. Then we're asked about the horizontal velocity. So we don't have velocity in the horizontal or velocity in the vertical. But there's one thing that we do have, and that's the acceleration in the y. The acceleration in the y is just equal to gravity. And gravity is equal to 9.8 meters per second squared. And now you might be saying, how are we supposed to solve for the vertical component of, the horizontal component of the velocity if we don't have an acceleration in the x? And the reason being that there is no acceleration in the x. The velocity in the horizontal component is going to stay constant due to the acceleration or the gravity only acting in the vertical component. There's going to be no acceleration in the horizontal component of the velocity. So our ax is going to equal 0 meters per second squared. And if it equals 0, that means this whole side of the equation, the plus 1 half axt squared, can be canceled out. So we can go ahead and just cancel this out since we don't need that. And that leaves us with our new equation of delta x is equal to vxt. And since we're looking for the vertical component, we're going to want only vx is what we're going to be wanting to solve for. But the thing is, we don't have t. We have our delta x, which we set up here is 3 meters, and our horizontal, which is our vx, is what we're solving for, but we don't have our t. But one thing that you notice, if you look at our equations, is that the t does not have a subscript at all. The reason being, the time is the same in both the horizontal and the vertical component, because the only thing pulling the ball down in the vertical component is the acceleration. That means that the time the ball takes to touch the ground is dependent on the height of where it drops from, because the acceleration is going to always be gravity on Earth, since that's Earth's gravity constant, and the only thing changing is going to be the distance or the height, so the delta y. With that knowledge, we can go ahead and find the time by using this equation up here to solve for t. So with that being said, we can plug in our known values. So delta y we said was 10. We know that Vy is going to be, in this case, 0, because here we can see that the object is starting to travel, as I said, tangent to the target, meaning that all the velocity is in the horizontal since it's straight. So that means there's no vertical component, meaning that the Vy is just going to be 0, and it's going to be times t, but this will just become 0 times anything is just 0, so we can keep that 0, and then that's plus 1 over 2a, which is 9.8, so we'll say 9.8, and that's t squared. So then we'll just multiply this by t squared, and t squared is what we don't know, so we'll keep that as that. Now, when we do this, we're going to do 1/2 times 9.8, which gives us 4.9 t squared is equal to 10. They're going to go ahead and divide by 4.9 and divide by 4.9, and then we're going to go ahead and take the square root of this, the square root of that, because we're going to have the t squared, so that's going to get rid of the square. So then that gives us the value of t is equal to 1.43 seconds. And now that we have our t is equal to 1.43 seconds, as I said, the time is the same in the x and in the y direction, we can go ahead and take this value of t and just plug it straight back up here. And when we do that, we'll have delta x, which we said was 3, is equal to vx, what we're solving for, and then t, which is our 1.43. And to get Vx by itself, we'll just divide by 1.43, so this cancels out to 1, and this divided by 1.43, giving us that Vx is equal to 2.097 meters per second. And if we look at our answer choices, if we go ahead and compare all the values, we can see that choice C, which is actually equal to 2.12, is close to our value of 2.1, leaving us choice C as our correct answer. If you guys have any questions or anything that makes sense, please comment down below. I'd love to go ahead and go through all those questions and answer them. And I hope you guys enjoyed the video. If there's any suggestions or any improvement you guys think I can do with this new setup, please comment down below. And with that being said, I hope you guys enjoy your prep, and remember to enjoy life.